This is for Dr. Lewis, Calculus 1 class. Derivative of the function f of x with respect to the variable x is the function f prime whose value at x is f prime x equals the limit as h approaches 0 f of x plus h minus f of x all over h. Just to give you a clear picture of what I am talking about is right over here. You have f prime of x as the limit approaches 0 is all equal to f of x plus h minus f of x all over h. Derivative equals slope equals instantaneous velocity equals instantaneous speed. If a function is not continuous, it doesn't necessarily have to have a derivative. If it has a derivative, it is also continuous. Continuity and derivative have a strong relationship. They both go hand in hand. Point slope formula. Y minus y1 equals m times x minus x1, which can be used along with the definition of derivative, which I first gave you right over here, going back to this, to find the equation of a tangent line. Anytime you're asked to find a tangent line, think of a point slope formula. How to find derivative using derivative rules. D over dx is a meaning of derivative with respect to x. X is always independent. So when you see something like d over dx, it's simply just stating derivative of something equals this. Derivative of a constant. When we think about derivative of a constant, anything of a constant is always equal to 0. So going over here, derivative of pi equals 0. Pi is a constant. Derivative of 6 equals 0. 6 is a constant. If it was derivative of 1, it will still equal 0. Derivative of 10, it will still equal 0. Power rule. We know to use a power rule when x is raised to an exponent. So basically we have over here this example right here. F of x is equal to negative 1 over 5 x to the 5th. That's a power rule right there. What you would do is take f prime of x, take that 5, which is the exponent on the top right there, multiply it by negative 1/5 and reduce the power by 1. 5 minus 1 equals 4. So your final answer when you multiply 5 times negative 1/5, you get negative x over 4. Or you can also write it as negative 1x over 4, but you don't necessarily need the run in front of the x. Constant multiple. Derivative of c f of x is equal to c derivative of f of x. This is how that example would look right there at the bottom. We have f of x is equal to x negative 3 all over 5. We first do f of x is equal to 1/5 x minus 3. We take f prime of x is equal to 1/5 derivative of x minus 3 to get 1/5 times negative 3x minus 4, which is all equal to the final answer as negative 3x to the negative 4th power all over 5. Product rule and quotient rule can be similar. The only difference is with quotient rule, you have to divide the bottom by the square of it. And you subtract the top portion, which is the numerator, unlike the product rule, which involves addition in the numerator. So with the product rule, we first do the first function times the derivative of the second function plus the second function times the derivative of the first. With the product rule, keep in mind you need to have two functions in order to use the product rule. So the quotient rule is pretty similar, except we take the first function times the derivative of the second function minus, there we go, that's the difference right there, the second function times the derivative of the first, all over g of x squared, which is the bottom square. So you have to remember to do that in the quotient rule. In order for you to also use the quotient rule, you have to have an x at the top and an x at the bottom. If you do not have an x at the bottom, you have to use the product rule for that. Okay, we have derivative of e to the x. Anytime we have derivative of e to the x, it's simply e to the x. We could see over here, I have included a graph of what f of x of e to the x looks like. We all know that with an exponential function, when you graph that, you start off really small and then you gradually come all the way up. Now, something that everybody has trouble with remembering are the trig functions, derivative of trig functions. For me, I kind of like finding the derivatives of trig functions only because it's kind of challenging, but you kind of get to maneuver your way into finding the answer. So right here, I have included all of the 6 properties, which is sine, cosine, tan, cosecant, secant, and cotangent. So this is how I start out by remembering these functions. I put down my sine, cosine, and tangent, and I've also put down the reciprocals of each one of those. Afterwards, I began by filling each and every single one of them. The two that everyone usually remembers is the derivative of sine of x and derivative of cosine of x, which is the sine of x, the derivative of that is cosine of x, and the derivative of cosine of x is negative sine of x. So when we try to find the derivative of tan of x, I always like to remember that it always starts with the same thing at the top, which is cosine. It always starts with the s. So I know that it's not sine, so I obviously remember that it's secant. And how I remember that is weird. I like to add cosine and sine 1 and 1 to get 2. So I always remember, oh, secant has to have a square in it, so I always think of it as secant square of x. So now to do the other side, the reciprocals of each and every single one of them. So for cosecant and secant, how I remember them is that I just look at cosecant and I look at secant, and I know that the first terms would always be what they're asking. So derivative of cosecant, I know that it's always going to be cosecant, and I have to remember that cosecant on the left side always is going to have a negative on it. So for the first part, the derivative of cosecant, I know that I have to have 2. This is part 2 from the video that I had made before for Dr. Lewis Calculus 1 class. I was explaining the derivative of the trig functions before the camera got cut off. So just going back, just to roughly explain it, this is everything that I had, which involves the 6 derivatives of the trig functions right here. And I had previously explained them in my previous video before it got cut off. So the last thing that I'm going to explain is the chain function, which is what we have been doing so far in class. Basically, the chain rule involves taking the derivative of the outside, leaving the inside alone. The answer to what causes a person to have a chain rule is when you have more than just x or t or even g or whatever variable is used in the function. So we have an example right here of a chain rule, which is f of x is equal to negative 5 cosine of x, all to the exponent of negative 4. So we take outside function right there, we take the exponent, multiply it by negative 5 to get 20, reduce the power by 1, which gives us 20 cosine of negative 5, reducing the power again by negative 1 of x, and taking the derivative of cosine of x to get negative sine of x. After 1, we take 20, multiply it by the negative in front of the sign to get the final answer to equal negative 20 cosine of negative 5 of x sine of x. So that is everything that we have right there. So just a quick review on everything that we talked about. We talked about the derivative of a constant, power rule, constant multiple, the quotient, the product. We just talked about the chain rule. We talked about the 6 different trig function derivatives. We also talked about the definition of a derivative of a function with respect to the variable x. as h approaches 0, we talked about derivative equals slope equals instantaneous velocity equals instantaneous speed. And if a function is not continuous, it does not necessarily have to have a derivative. If it does have a derivative, it's continuous. Those relationships go hand in hand. We talked about the point slope formula and how it could be used along with the definition of a derivative to find a tangent of a line. And we also talked mainly about what d over d of x is, which is just stating that derivative of something equals this. Okay, thank you so much.